Yeah. Yeah. So yesterday we discussed about for writing the manifest file, we need a API version, kind, metadata, and a spec. So what is API version, guys? API version represents the version of our API like V1, V2, V3. Same like as a V1, V2. So what is the important in the manifest file, guys? API version. I will write down another new file. Default.yaml. So in the default.yaml, so what is that, guys? API version. So API version, something like V1. So metadata kind. What is that, guys? Kind, metadata. So metadata. And what is that, guys? Last one. What is that? A spec, right? So the starting manifest file, the starting three hyphens and the end with three dots. End with three dots. So this is the manifest file. So this is the manifest file of the Kubernetes manifest file. So the manifest file starts with the three hyphens, end with three dots. So what is that, guys? API version kind metadata spec. Kind metadata spec. This is the manifest file. So this is the manifest file. Yeah. So what is that, guys? So API version represents the version of our API like V1, V2, V3. Kind represents the what is the purpose of the manifest file. So what is the represent of manifest file, guys? The manifest file represents creation of a pod, service, or a deployment. Pod, service, or a deployment, guys. Guys, understood? Guys, mute yourself. Yeah. So kind represents the what is the purpose of manifest file. So to create the pod, to create the service, to create the deployment. Metadata represents the data about the data is nothing but a labels. What is that, guys? Labels. So label is the important, guys. So labels is equal to, so label will represent the service later, guys. So metadata spec represents the specification. What you want? What you want, guys? You want a container. Specification spec is nothing but a specifications. We want a container. We want a container. Guys, understood? Yeah. So get parts. Kubectl apply -java pod yaml describe parts. Describe the Java part. So something like kubectl get parts -o void. So we can access the pod across the cluster using a pod IP. Pod IP. We cannot access the pod using the pod outside of the cluster. I will show you guys. Pod lifecycle. So make a request to the API server using manifest file to create the pod. API server will save the pod info to the etcd. Scheduler find the unscheduled pod info. So this is the unscheduled pod info, right? And schedule that pod for the execution in the node. So who is scheduler will schedule. So who will enable kubelet will see that pod execution schedule. So we'll see the and it will trigger the Docker runtime. Docker runtime when runs the container, runs that container inside the pod. So pod is ephemeral, living for a short period of time. When pod is recreated, then the pod IP will change. It is not recommended to access the pod using the pod IP, guys. So we will use Kubernetes service component to execute the pods. So Kubernetes service will make pod accessible, discoverable inside the cluster and outside the cluster also. So when we create a service, we will get a one virtual IP address, the cluster IP. So cluster IP will register in the Kubernetes DNS with its name. So what is a Kubernetes service? A service is responsible to make our pods discoverable and accessible inside and outside the cluster. What is the service? Service is responsible to make our parts discoverable, accessible inside and outside of the cluster. Service will identify the pod using the pod label. So how we can identify the service? So we can identify the service by using the pod label. You see, guys. So here the pod manifest file. So this is the service manifest file. So we have a two manifest files. So one is a pod manifest file for creating the pod. This is the service manifest file for uh, for accessing the pods inside and outside. So here the label equal to able app Java web app specification container. Here what is the specification to create the container? But here what is the specifications? Spec equal to type cluster IP. So what is the Kubernetes services? Cluster IP, node port, load balancer. This cluster IP, so it will connect the within the cluster only. It will enable within the cluster within the cluster. So with outside of the cluster we can use the node port. Outside of the cluster I want to access the that container, right? I want to access the website. Website is running in the container. I want to access that website. How you can access? So we need to enable the outside of the network. Who will enable the outside of the network? That service manifest will enable the will enable the IP address to the outside of the network, the cluster IP or a node port. Cluster IP or a node port. Guys, understood? The cluster IP, node port, load balancer. So K8 is service type, something like the service to expose the pods. How you can expose the pod? By using cluster IP, node port, and load balancer. So cluster IP is nothing but a, so within the pods, so within the cluster only, it will enable. Outside of the cluster, it will not enable. So outside of the cluster is nothing but the end user wants to access this container, means access this website. It will not enable the outside network. So that's the reason. Cluster IP. So it enables within the cluster only. Pods are the empirical. Pods are short-lived objects. So pod IP will change when it is recreated. For example, guys. For example, so P1, P2, P3. These all are the pods. So P1 pod contain IP, P2 pods contain IP, P3 pods contain IP. So P2 pod something like pod 2 is crashed, guys. So it will create another pod. So the IP definitely, if you recreate the pod, it will definitely change the IP address. So if you access through the IP address, this website is in the P2 container, but now P4 is created. So the IP address is changed. Is it accessible via pod? So the IP address is changing, right? So this is the not a good way to expose the pods. We can expose by using the cluster IP. So we can by using the cluster IP or node port or a load balancer. So for this it will create a cluster IP. So whatever the pod, this is the this node having the cluster IP. So this node having the cluster IP, or whatever the container. For example, this pod having the cluster IP. So whatever the pod crashes, it will access through the cluster IP. Okay, cluster IP. What is a cluster IP? When we create a pods, every pod will get a unique IP address. Every pod will get a unique IP address. Unique IP address. So we can access pod inside the cluster using its IP address. So we can access the pod inside the cluster using its IP address. Only inside. Note, pods are short-lived objects. When pod is created, its IP will be changed so that we cannot depend on pod IP to access. To expose pod access within the cluster, so we can use the cluster IP service. Cluster IP will generate one IP address to access our pods within the cluster. So cluster IP will not change when the pods are recreated, but the pod IP will change, the pod is recreated, but cluster IP will not change. Cluster IP will not change. Guys, you see here something like EKS service example. For example, so this is the database service, guys. So the user can the end user can connect to the database server. No, So what he will connect? He will connect the front end only. He will connect the front end only. Front end only. For example, this is the application architecture, guys. User interface, front end, back end, DB. Right, guys? So for example, guys, mute yourself, guys. Yeah. So front end, back end, and DB. For example, front end is nothing but a www.facebook.com is the front end, right? So when you give the username password, then a business logic will be executed, and then it will be checked the if the username password is correct or not. So then it will open the another page, right? The end user directly cannot connect to the DB server. So DB server, because of this is a database server, right? Just the user directly connect to the front end, right? So front end will connect to the back end will connect to the database. From these two, it will connect. Do we need a expose outside these two? No need of a expose to outside. So we can connect these two servers a cluster IP. Cluster IP is nothing but a within the cluster we can connect. Outside of the cluster we can use the front end. So we cannot give the DB access to the end user, right? So for end users we will give access to the front end only, means application. So within the cluster we can use the DB access. So for this cluster IP we can use for our backend parts, means like backend and DB. So backend and DB, guys, here you see. So something like this is the database. This is the database node. This is the backend node. This is the backend node. This is the database node. For example, so this database having the parts P1, P2, P3 parts. This database having the P1, P2, P3 of parts. So these parts contain the this part. So this every pod having the IP address, right? So we cannot access directly through the IP address. We can create a cluster IP for this pod, cluster IP for this parts, right? One IP address will assign, so we can connect to this from this to this by using cluster IP, so why we cannot connect to the pod IP, pod? Because of if pod created, pop deleted, it will create automatically another pod, and the pop IP address will change. For the front end purpose, for the front end application purpose, we can use the NP node port. We can use the node port, guys. Node port. Is understood? So the cluster IP, right? Yeah, guys. The cluster created yesterday, right? But so we didn't check the what are the nodes created, how many nodes are created. This is the cluster, right? So this is the cluster. But in the EC2, there are two default. I already told you, right? Default two instances will be creating. So default two instances will be creating Hari IT cluster 4. Cluster 4. You see, guys. So what is the IP address? 116. This is the IP. What is the IP address of this? So the IP address of this 184. We created two worker nodes, guys. These are the two worker nodes. So this is the EKS services. So this is the control plane. So created two worker nodes. So control plane created two worker nodes, guys. Two worker nodes. Yeah. So how we can connect? This is our remote mission. So this is our remote mission. So what is that, guys? Ubuntu, right? Ubuntu is the username. So Ubuntu is the username. kubectl get parts. kubectl get parts. nginx one pod is running. Yesterday we ran with the manifest file. Get nodes. kubectl get nodes. What are the nodes, guys? The IP address is 37.1 and 116. So 37 and 116, these are the two nodes, worker nodes are created. What is that? So 14.37, 35.116. 14.37, So one is 14.37. The other one is 35.116. These are the two worker nodes. These are the two worker nodes. Yeah, guys understood, right? So kubectl get parts -o wide. It will display the pod is running, nginx pod is running 25 hours ago, the IP address of the pod and the node. So which node this pod is created? 116 node. So in 116 it is created. What is the 116, guys? Yeah, 116. Here the pod is created. Here the pod is created here. Something like kubectl delete all -all, guys. Yeah. So pod nginx is deleted. Service Kubernetes is deleted. Now you check kubectl get pods. No resources found in the default namespace. Kubectl get svc. kubectl get svc. So the default cluster IP is created. The default cluster IP is created, but our cluster IP is not created. So right, that service Kubernetes is deleted and the pod is deleted. The pod is deleted. Now your cluster is EKS cluster is empty. Your Kubernetes cluster is empty. Guys understood? So what is the cluster IP? So cluster IP, when pod creates, every pod will get a unique IP address. We can access pod inside the cluster using its IP addresses. Pods are short-lived objects. When pod is recreated, its IP will be changed so that we cannot depend on the pod IP to access. To expose pod access within the cluster, we can use the cluster IP. So cluster IP will generate one IP address to access our pods within the cluster. Okay, so cluster IP will not change when the pods are recreated. Yeah, kubectl delete all -all. We deleted, guys. So yeah, service. How you can create the service manifest? How you can create the service manifest? So this is the cluster IP. So cluster IP spec type equal to cluster IP, selector equal to label. We can represent here label. So this label, this app, Java web app needs a inside the cluster access, node port, outside the cluster access, load balancer. So load balancer, right? kubectl get svc. There is no svcc. Schedule a service using the manifest file kubectl apply -f java web app svc.aml. So kubectl get svc. So in the cluster IP, one virtual IP will be assigned to our service. Using that cluster IP, we can access service within the cluster. If you want to expose our service outside the cluster, we need to use the node port service. So node port service. So node port service. So node port service is a used to expose the pods outside the cluster also. So when we use the node port service, we can specify node port number in a specific manifest file. So if you do not specify the node port number, then Kubernetes will assign a random node port number to our service. So node port range equal to 30,000 to 32,767. We can provide in this range, in between range. Node port service. So node port, so selector API Java port to target port API. If you provide the node port, or if you are not providing the node port, it will take the default. So what is the range of the node port in Kubernetes cluster? What is the range, guys? 30,000 to 30,000, 32,767. Guys, everyone can speak out. What is the range of the node port in Kubernetes cluster? What is the range of node port in the Kubernetes cluster? Guys, respond. So what is the node port?
30,000 to 32,767.
Very good. 30,000 to 32,767. So this is the target port. So this is the host port. For the node port service, Kubernetes will assign a random port number. We can access our service outside the cluster using any cluster machine public IP with node port. Enable node port in the security group, guys. We can enable the node port. So URL access to app, something like this is the access. So load balancer, it is one type of Kubernetes service. It is used to expose our pods outside the cluster using the load balancer. For example, we have a two nodes, right? So we have a two nodes. Within the two nodes, we can create a load balancer. So when we use the load balancer as a service type, then one load balancer will create in the AWS cloud. Using the load balancer URL, we can access our applications. So load balancer will distribute the traffic to the multiple worker nodes in the round robin fusion. Multiple worker nodes. Multiple worker nodes. So this is the load balancer. So load balancer service, so something like a DevOps engineer created the kube config IAM. Yeah, this is the remote mission. Then you can created the uh, uh, control plane and the worker nodes, two worker nodes having the pods P1, P2. So this is created as a AWS LBR load balancer. So the end user, when you click the end user, it automatically comes to the load balancer. So based on the traffic, it will move, it will go to the P1 or it will go to the P2. Guys, understood? So the Java type equal to load balancer, type equal to load balancer. Here type equal to node port. So cluster IP type equal to cluster IP. Guys, understood? So what is the Kubernetes service? The Kubernetes service is pod directly cannot access the outside of the cluster. Outside of the cluster. So and the so if pod deleted, it will create the Kubernetes is a management orchestration tool, right? It automatically created the another pod with the different IP addresses. We cannot access the either cluster within the cluster or the outside the cluster because of the pod IP will delete whenever it's recreate. Whenever it's recreate, that's the reason we can create a one cluster IP. So that cluster IP we can access within the cluster. And if you want to expose that website or a container from the outside, we need to create the node port, right? So for example, if you want to create the load balancer is nothing but created a two worker nodes, right? So between two worker nodes, we need a load balancer. We can create the load balancer. Those are the Kubernetes services. So what are the Kubernetes services? Kubernetes services are cluster IP, node port, and load balancer. Guys, tell me, what are the Kubernetes services? Guys, so what are the speak out? What are the Kubernetes services?
Cluster IP, node
Cluster
port,
IP to node port to load balancer.
Node
Now you
port and
understood.
load balancer cluster IP.
Yeah, very good. Very good. So now you understood the how we can expose inside and outside of the cluster. Now you got it. Now you got it, the pod, how to create the pod, the manifest file, service manifest file. We can create it, guys. Guys, in the yeah, so you guys are installed the that VS code, right, guys? Guys, you guys already installed the VS code, right? While creating the Terraform.
Yes, sir.
Yes, right? Yeah. You guys can install the plugin for this Kubernetes, guys. So what is the plugin, guys? Kubernetes template plugin and the YAML plugin. You guys can install these two plugins. So for example, YAML plugin, Kubernetes YAML, just YAML, this is already installed. That's the reason it is not showing install. So you guys can click YAML, then install, guys. And Kubernetes also, Kubernetes. So Kubernetes plugins, you guys can, I already installed the Kubernetes. Yeah, Kubernetes templates. So I already installed the Kubernetes templates. That's the reason it is not showing, guys. Okay, or else something like this is Kubernetes. You guys can install Kubernetes. Okay, it is installed. It is installed the Kubernetes service. Okay, so whenever we create the service, right, it automatically showing the differences. Okay, now now you understood, right? You know how to create the a manifest file. So manifest file, right, guys? So I will create the manifest files. Yeah, so this is, so what are the manifest files are here? You need to restart or duplicate session. Reset the terminal. Duplicate session. Ubuntu. Yeah, guys. So Ubuntu. So I want to create a something like, I want to create the file, manifest file in the VS Code. Then I will copy here, guys. So what are the nginx pod YML, cat nginx.yml. So this is the which pod, guys? This is the nginx pod. So this is the nginx pod. I will create a new file, nginx.yml. So this is the YML manifest file. Yeah. So this is the a container. So API version, guys. Starting, what you guys can do, you can start with the 3 dots, end with the 3 dots, right? So I already created API version v1, kind pod, metadata, name equal to nginx, labels, app equal to nginx, spec containers, name nginx, image. So it is getting from the image, or if you want to provide your image name, let's check, guys. Your image name is, something like GitHub. No, not GitHub. Our image will be in Docker Hub, right? hub.docker.com. Yeah, sign in. Yeah. So what is my Tomcat, guys? So 15 days ago, 6 months ago, 15 days ago. Yeah, let's use this copy address 89 Tomcat 8067 copy. Yeah, I can use this image. I can use this image and GNX, right? I will modify this to my Tomcat 9. So this is my Tomcat 9. This is my Tomcat 9. Label equal to my Tomcat name equal to my Tomcat 9. So right, guys. So I will create the, so this is my nginx.aml, right? This is my nginx.aml. Command C, Control S, yeah, it's saved, guys. Control S, it's saved. It's saved. Yeah, it's saved, guys. So this is the, so this is the notation, right? Yeah, you guys can Ubuntu, right? Yeah. So VA tomcat -pod.aml. Yeah. Yes, guys. API version v1, kind equal to pod, metadata, name equal to my Tomcat 9, label, app. So this is the metadata is nothing but a data about the data. So definitely we need to create the labels, guys. We need to create the labels because of, so we need to enable the port, right? We need to enable the port within the cluster or outside the cluster or a load balancer. Based on this label, we can expose, guys. Based on this label, we can expose. So the container is the container port is something like 8080 or whatever it may be. So 8080 I'm giving. So WQ. So then how you can create the, how you can create the cluster, how you can create the pod, guys? What is the command? Kubectl apply -f the manifest file tomcat -pod.yaml. Yeah, so pod 9 my tomcat 9 is created, right guys? kubectl get pods yeah, my tomcat is created. So container creating and status container creating. Yeah, it's running now. So now running now 20 seconds, 22 seconds ago. So -o it will show the -o it will show the a node, which node which node the IP is created. Now 37 before 116. Now 37 in the 37 node it will created the pod, guys, the 37. Now I am trying to create a another that cluster IP creation. So that cluster IP, right? So we want to provide the another manifest file. The manifest file is, yeah. So again, you can create a API version, kind service, metadata, name equal to, we can provide the label. We can provide the name SVC, something like spec type equal to cluster IP. Selector we can create the selector as a label. Guys. So we can create the where is that, guys? Yeah. So here also, so we can create another called default.yml. This is the default.yml. So I will rename this default.yml to that my tomcat svc. I'm creating a svc YAML. So API version. So what is the API version, guys? So v1, that kind equal to, what is the kind, guys? So this is a tomcat. So this is the a tomcat. No, nginx, right here. So this is the my tomcat, guys. Rename it my tomcat dot 9. My tomcat 9. Yeah. So my tomcat 9 pod kind equal to pod, guys. Here, so kind equal to service. Kind equal to service. So metadata kind equal to service, guys. If you see service, it automatically created the template. It automatically created the template. You see, it automatically created the kind spec ports target port node port to target port to node port. So you can give, you cannot give, guys. Yeah. So if you want to set the spec type field to the node port and you want to a specific port number, if you can specify the volume in the spec port number. So if you specify a node port, so we are specifying a cluster IP. So we are specifying a type equal to cluster IP. Yeah, guys. So what is that, guys? So what is the name of the metadata? So metadata name equal to my tomcat 9 svc. So default namespace. So there is no a default namespace. We are not creating any default namespace. So just I'm creating a spec. Yeah. So metadata. So my tomcat svc. So spec selector equal to, so selector type. So selector. So what is the first, we can create the type equal to cluster IP. type equal to cluster IP, selector equal to, so we need to provide the selector, we need to provide the a label. What is the label, guys? A label of the selector, my tomcat 9, right? What is the tomcat? What is the label? My tomcat 9. So we can provide the a label of the so type equal to cluster IP. So then we can provide the selector here, guys. Selector. So selector, what is the selector? My tomcat 9. Yeah, guys, session affinity config, client IP. We don't need these, guys. We don't need as of now. We will tell you everything. So the ports. So what are the ports? Ports equal to so ports equal to hyphen port, guys. Hyphen port target port. What is the target port, guys? 8080 target port 8080. We are not specifying the node port. Okay. Yeah. So this is the, so you can delete this one also, guys. You can delete this one also. Yeah. So what is our so API version v1, kind equal to service, metadata, name equal to my tomcat.sec, spec type equal to cluster IP, selector equal to my tomcat 9. So ports equal to port 80, target port equal to 8080. Okay. Target port equal to 80, guys. Yeah. I'm saving this file. And I am copying this file. Copy, and I will create a, I think again we need to shit, guys. Shit. Ubuntu. Yes, right? So I'm creating another file. So another file. What is the file? My tomcat -svc dot YAML. So sorry, guys. So vi. So I'm creating this file, and I'm pasting the API version v1 kind metadata. Guys, the notation is wrong. Yeah. So API version kind metadata spec, both are the same. So name, metadata name, label, metadata name, I think we need another space. Data name, right? Data kind name spec. I think we need to create from the type, right? Metadata no type selector both are same. Ports from also same hyphen port, right? P hyphen port. I think you need to give one space. Port target port So we can give this to target port. Yeah, guys. Now I'm saving this. Yeah, kubectl get svc, kubectl get svc. Yeah, only one, that is default one. So I'm trying to create a another service. Kubectl apply -f. What is that, guys? What is that name? My tomcat svc.aml. An error validating my tomcat.error, validating data, missing required field, port. Right, guys, port. So I think -p port equal to port, right? So image ports, container port, app ports, ports from, I think, -ports, right? Port 80. We need to provide the port 80, target port equal to 8080, and the container port 8080, right? WQ. Again, we need to title kubectl apply. Yeah, error parsing my tomcat.svs.ml, error converting YAML to JSON, YAML line number 40 did not find the unexpected hyphen indicator. So where is that? VA shift S set new line number 10, kind. What is that, guys? Name equal to my tomcat 9 svc. Namespace, we are not providing the namespace, right? Just a spec type what is that, guys? Cluster IP, right? Cluster IP selector equal to yeah, we will provide this my tomcat 9 on port 80, right? Let's try this. Copy. Oh, guys, shit. Ubuntu VA. What is that, guys? My tomcat svc.aml, right? Enter. Delete everything. Insert. Pasted everything. Huh? Copy. Yeah, API version v1 service kind equal to service, metadata name, my tomcat 9, spec type. We'll remove these guys. We'll get confusion. Yeah. Kind service, metadata, my tomcat svc, spec type cluster IP, selector app equal to my tomcat 9, ports hyphen port 80, target port 8080 guys. Let's check. So kubectl apply hyphen f my tomcat dot svc. Yes guys, service my tomcat svc9 is created. Kubectl get what is that guys? Get pods or kubectl get svc. Yes, right? My tomcat 9 svc cluster IP is created. So cluster IP is created. Cluster IP is created. So for the for for creating the node port guys. So node port we need to provide the what is that guys? Node port. So node port we need to provide the node port right. Let's kubectl delete hyphen all hyphen all. It will delete everything guys. It will delete everything. Kubectl get svc. So kubectl get parts. Everything will be deleted guys. Everything will be deleted. So I want to create a one file guys. I want to create a one file for everything. So vi cat so cat my tomcat.svl. So this is the file right guys. So my tomcat 9, yeah. So this is the file. So I want to create the svc also the same file. So we can create, how you can create, you can use the hyphen and again you can create guys. Again you can create that so this is the cluster IP right. The same we can use this one and we can paste it here. So we can copy. Yeah, it's copied right. It's copied and paste. Yeah, it's pasted. Guys, I'm creating both. I'm creating the both pod file, pod manifest file and service manifest file, creating the same manifest file guys. Here we already created the cluster IP right. Now we will create the node port guys. What is that guys? Node port. Node port is for the outside of the network. So the selector same port, so target port, but we will provide the which port guys? We will provide the node port also. What is that? Node port. Yeah. So node port. So what is the node port range guys? 30,000 to 30,725, right? So we will give 30,000 722 guys. For example, I'm giving 722. So this is my manifest file. I'm including both. I'm including both guys. Yeah, here I'm creating a vi svc on pod.svc and pod.aml. I'm creating a svc and pod. So this is the API version v1 kind pod metadata name equal to my tomcat, label equal to app my tomcat, spec equal to container. So image, we can get the image Hare Krishna 857 from the Docker Hub. Ports equal to, here you can enable 8080 also. You can enable the port 808080. So what is that? Container port, guys. So the container port, so here the node port, node will get the one IP address, right? That IP address will connect to this port only. Okay, so we created the node port. Node port is nothing but a, so we can we can access outside also. So kubectl apply -f svc pod.aml svc pod.aml. So error validating svc pod.aml data field node port in Q80 validating svc pod error while validating the validation error service spec point unknown field node port in, yeah, yes guys. So what is the mistake here? The node port, so n is a small, guys. So n is small. Node port, then now you can try kubectl apply pod. Yeah, you see guys, pod is created. Yeah, pod is created, or also service is created. So with one file, so we can create the a pod and service, kubectl get svc, yeah, svc my tomcat node port equal to 10 100 1919 104 1919 104, and the kubectl get pods. So kubectl get pods, sorry guys, get pods. Okay, pod is running. I want to see the node. Which node? 37. Yeah guys, so what you can do, you can go to this server and you can enable the security group, guys. So we can enable the security group. So which is, what is that, guys? So that is 37 we need to, is this 37? Reload. Is 37? Yeah. What is this IP address? So this is 26. This is 37. Yeah. So go to the security and security group. You can go to the inbound, right? Inbound, edit inbound. You can add rule, custom port range. What is the port range, guys? So we can provide all, or we can provide that port range. We can provide this port range, guys. What is the port? Port is running 30. You see, guys. So this node port is running 3072. So we can create 30722. 30722. What is the 30722 port number? So all, save the rules. Save the rules. So the traffic, so 3072. 3072. Now let's check, guys. Now let's check instances. So what is this, guys? This is only, right, 37. Yeah, 37 public DNS, the port number. What is the port number, guys? 30722. 30722. Yeah, you see, guys. So the tomcat is deployed. The tomcat is deployed. So what is that, guys? Slash LA6. What is that, guys? Last time we is this L6A, I think L6A code. Tomcat sample code. We took the sample verifier, right? Last time. What is that sample? This is the sample one, not this one. This one, this one, guys. Lab 6A. Lab 6A. Guys, understood? Guys, understood? Yeah, your application is deployed in this container in the pod. The pod having a IP address. A pod having the IP address, but we are not contacting to the IP address of the pod. Yeah. So wide IP. So this is the IP address of the pod, but we are not using this IP address of the pod. We are using the node port to enable the node port because of so if you delete kubectl delete pod name. So pod name, what is that? My Tomcat 9. Yeah, let's try this. Now let's try this. Yeah, site cannot be reached because of the pod is not running. So that is the reason we are not able to access the website. We are not able to access the website, right, guys? So 192.168.26.10. But if the pod is deleted, so how we can create the pod, guys? How we can create the pod? What is the Kubernetes? Kubernetes orchestration is nothing but a auto healing. What is that, guys? Auto healing is nothing but so whenever it deleted, so we need to create it, right, guys? We need to create it automatically. But kubectl get nodes, get pods. So no pods are created. So what is the default behavior? The Kubernetes automatically auto healing. Auto healing is nothing but whenever the pod is created. So whenever the pod is deleted, it automatically created. How we can create? By using the replica set, by using the replica controllers. So load balancer, right, guys? You can just create the load balancer. It will automatically create the load balancer. Let's check kubectl delete all all. It will delete everything. So now vi svc pod.yaml. So here you can provide the instead of node port, you can provide the instead of node port. Guys, what you need to provide? Guys, speak out, guys. Sorry, load balancer. What is that, guys? Load. Yeah, so load balancer. Load balancer, we cannot provide the node port here. Directly it will take the default one, load balancer. Okay, so again kubectl apply. Yeah, so now you can check kubectl get pods. pod is created. kubectl get svc service, kubectl service. You see guys, load balancer is created. So by using load balancer, you can connect the server. So by using load balancer, so we can connect the server. What is the port, guys? Port is 3232369. What is that? 32369. 32369. 32369. By load balancer, we cannot connect the 32369. The port is correct or not? Let's check the load balancer, guys. Load balancers. You see guys, load balancer is created. So this is the A record. This is the DNS name. This is the one, right? We are using. But why it is not exposed? 32369, right? We need to enable the security group for the both. Yeah. That is the, yes guys. The you can go to the instances, then you can enable the security group. You can enable the security group. Name role security groups. So what is the IP address, guys? You need to edit the inbound rules. So we can specify all. Not all traffic, all. So we can save the rules. So this is the one instance and the other instance also. So we can create the security group, go to the security groups and inbound rules, edit inbound rules, all traffic. So this is the one, right? I created just now. Now I want to go to this security groups. What is this here? Inbound rule, all traffic, all traffic, all. So this is the Eclipse cluster 9940. Yeah, both everything is similar. Load balancer is the DNS name copied. Yeah guys, you see it is opened /LBA now. What is that? lab 6. I will copy this, guys. Copy lab 6 dot list. Yeah, guys, understood? So this is from load balancer, so node port and cluster IP. By using cluster IP, we will not enable, guys. We will not enable. Guys, understood? Guys, understood or not?
Yes, sir.
Yeah, right?
Yes, sir.
Yes, shit. This was done now. Duplicate session. Ubuntu. Yeah. You guys can use what is that, guys? Cat pod svc pod.yaml. Yeah, guys. So this is the file. I'm creating this file. Where is that, guys? I provided you, right, guys? Yeah, guys. So here I'm creating a file main, add a file name equal to svc pod.yaml. svc pod.yaml. So this is the commit changes. Yeah. So nginx pod.yaml. So this is the guys. This is the pod. You guys can check it. And the svc.pod. So this is the load balancer. Yeah, guys. You can change it. Load balancer. You can change it. You can change it whatever it may be, guys. Here we want to change our load balancer. Okay. Nice. Now you understood, right, guys? So nginx svc. This is also nginx svc, guys. Notepad. I created a different svc file. So then this is the svc both nginx pod, guys. Okay. So this is the replica set and replica contour. We'll show it, guys. So this is the most important. I want to auto healing. Auto healing concept will enable on the replica set and replica controller. We'll show you tomorrow, guys. Guys, understood? Cluster, node port, service load balancer. Now you understood, right, guys?
Yes.
Yeah. Very good. Yeah. So pod is a smallest pod life cycle, guys. Again, and pod life cycle. Pod is a smallest building block that we can run in the Kubernetes cluster. We are using kubectl to send request to the control plane to create a pod. API server will receive our request and will store the required details in the etcd. Scheduler will find unscheduled pods and it will schedule in the worker node. So node agent. Who is the node agent, guys? Kubelet will see pod schedule and it will fire Docker engine. Docker engine will run our containers. Pods are ephemeral, short-lived objects. So manually created pod is not recommended. So in the above scenarios, we have created the pod manually. It is not recommended. If we create the pod, then Kubernetes will not provide high availability. So let's test it by deleting our pod. So once the pod got deleted, Kubernetes not creating the another pod and the application went down, not accessible, right? If you want to achieve high availability, then we should not create the pods manually. We need to use Kubernetes components to create the pods. Then Kubernetes will provide a high availability. So note, high availability means always our application should be accessible. So what are the components, guys? Kubernetes components for the high availability. So replication controller, replication set, daemon set, deployments, and stateful set. So what is that, guys? A replication controller, replication set. So replication set is nothing but if you set the replica set 3, always your pods running 3 pods. If we delete any one, it automatically creates. So what is a replication controller? It is one of the key feature in the Kubernetes. It is responsible to manage pod lifecycle. It will make sure given number of pods replicas are running at any point of time. Note, if any pod got crashed, deleted, dead, then replication controller will replace it. So what is that? A replication controller will replace it. A replication control is providing facility to create a multiple pods and it will make sure pods always exist to run our application. Using replication controller, we can achieve high availability. Replication controllers and pods are associated with the labels and selectors. So what is that, guys? Labels and selectors. Pod manifest, node port service manifest. Pod API version kind metadata spec. API version kind metadata spec. So what is that got a manifest file? So the manifest file for the node port service kind service metadata, so type equal to node port, selector equal to this one port, and the API version the pod manifest file. Kind we are providing the replication controller. What is that, guys? So before we provide the pod, now we can provide the replication controller. So replication controllers spec replicas. So how many replicas? One replica. Selector, how many replicas at a time? One replica. Selector equal to app. Template equal to metadata, something like label. So spec. So this is what we added. We added the metadata of the replication controller, metadata of the replication controller. Guys, understood? So this is the manifest file for the replication controller. So view replication controller.yaml. So this is the service of the node port and the something like node port and replication controller. Replication controller. So what is the replica set? It is the next generation of the replication controller. Both replication controller and replica set are both same, but the next generation of the replica controller is a replica set. It is used to manage pod life cycle. We can scale up and scale down pods using the replica set also. So the only difference between replication control and replica set is a selector support. So what is that? Selector support. We have two types of selector, equality selector and set based selectors. So what is that? Equality selectors and set based selectors. But in the replication controller, there is no selectors, equality selector and set based selector, just a selector. So but in the replica set, so we have a two types of selectors. Only the difference between replication control and replica set is a selector support, equality selector and set based selector. So equality selector, by default it is a equality selector in the replication controller, but set based selector is nothing but we can set the set based selectors. So replication one versions control replication set. So daemon set. So daemon set, pod creations, deployment. Finally, a deployment. Finally, so deployment. What is the strategy of the Kubernetes? Kubernetes strategies. So what is the strategies, guys? So recreate and rolling update, blue-green bundle deployment. Okay, guys. So maybe so in 2 classes we will show we will close the Kubernetes. Guys, little bit you understand about the Kubernetes right now. Guys, understood?
Yeah, bro.
Yep, thank you. Thank you, guys. So we'll continue from Monday.
Monday deployments ఉన్నాయి.
Monday morning deployments ఉన్నాయి.
Okay.
So if you want, you can come, guys. అందరు రండి, అందరూ ఒక సెకండ్.